Today we are learning about simplifying square roots in expressions. We've already solved square roots and found the perfect squares. So, first things first, let's talk about what that means. If you look at these two examples, you see the square root of 4 times the square root of 16. If we simplify that, they're both perfect squares, so you can say 2 times 4, you get 8. But we could also say that this is the same as the square root of 4 times 16, all under the same radical sign. So when you do that, you get, and you multiply inside the radical sign, because that's a grouping symbol, you get the square root of 64, which is also 8, right? Well, that leads us to this property. Okay, we're going to write this down. It's the product property of square roots. So, if you have two numbers multiplied together inside a radical sign, so the square root of a times b, that's also equal to each term separately. The square root of a times the square root of b, and they have to be positive integers, greater than or equal to 0, then you can multiply them together and you'll get the same answer. Whether you separate them as terms or do what's under the radical sign first. And here's our example. The square root of 9 times 7, all under the radical sign, is the same as saying square root of 9 times the square root of 7. That's square root of 9 is 3. That's perfect square. So that equals 3 root 7.
Oh, because it's 3 times...
Right, exactly. You simplify it, that's as far as you can go.
Oh, so on the square root of 7 would be like a really long decimal, probably. So then you can 3 times that and that's your answer.
This is more accurate to say that because it won't cut off. Now, we're going to be practicing getting radical expressions in simplest form, and you need to know what that looks like. So, it means all perfect square factors have been factored out. You could do that here. That's as far as we can go. Secondly, there are no fractions under the radical sign. Write this down because you want to be looking for this to know that you have gone all the way to simplification. And also, no fractions in the denominator of any fraction. So fraction and fraction. So that's how you know when your expression is simplified. So our first example is to simplify a radical expression. And the instructions simply say, simplify the expression. Numbers are terms underneath the radical sign. And variables, because we're going to lead up to that as well.
So you basically do like a factor tree and then multiply all those numbers.
Well, factoring out perfect squares is part of it. That is true. So, first things first, write down the original expression here. It's just the square root of 675.
So is there a function for this or a calculator?
You have to do this by hand. And so the first step is to factor using the greatest perfect square factor. What two numbers multiplied together make 675? We want to try to factor out any perfect squares we can to get it simplified. That is a step to getting it simplified.
5 and 2 by 675.
Yeah, try it out. What is 675 divided by 5? You know that is one factor. It ends in a 5.
135.
Okay, but what is a perfect square factor? Is 5 a perfect square factor?
No.
It is a factor, but it's not. Okay, 25 is. Is 25 a factor of 675?
Yes.
Okay, then what is, so 25 times what gives you 675? So you have calculators.
27.
Yes. Okay, 27. Okay, so we're getting there. Now the property of square roots, recall what it says? When you have two terms under your expression, or your radical sign, you can separate them out, right? Well, do you notice 27? Does it have any perfect square factors also?
No.
Yes,
9.
Yes.
Yes.
9. So this also could say square root of 25 times 9 times 3, right? Yeah, because
Once you do 5 times 5 times 9 times 3.
we don't need to get it to its product of primes. That's what you're thinking
Well,
of. We want to get it to, we want to factor out perfect squares. Because that means we're going to have a whole number already outside of this. So we know that this is the same as saying 20, square root of 25, square root of 9 times square root of 3. Right? Yeah, what are the square roots of these first two? 5 times 3 times the square root of 3. Right? Now what? We have to still simplify because we have too many operations. What is 5 times 3?
15.
Okay, so 15 root 3 is your answer.
Wait, I have a question.
Yeah.
What is the square root of 675? Like,
Simplify it. Take out all perfect square factors.
well, isn't that the same as saying, what's the square root of 6 times 7 times 5?
These are not three different numbers. This is one whole number. 675. Okay, so that's different.
Yeah, what if the number's prime?
You have to find, you're going to be practicing getting out all perfect squares. There may be a prime number factor in there, but there's also a perfect square factor. Okay? Our next type of example is simplifying a variable expression. So we're going to introduce variables under the radical sign. Write this down, James. So here's our variable expression. I'll add a little bar because this doesn't come up very much. So the square root of 176a squared. Well, we need to simplify this as far as we can go. Okay, so the same step applies first. Factor using the greatest perfect square factors. Well, what do you think 176 could be multiplied by? Think about that. Well, we want perfect squares. Maybe 4, right? Is it divisible by 4? Let's give it a try. Get your calculators out. Guess and check if you have to.
44.
Oh, okay. So 4 times 44 times a squared, right? Well, this is a perfect square factor. This is 11. Oh, this is also 11 times 4, right? We take out another perfect square factor out of that. So this is the same as saying 4 times 4 times 11 times a squared. Okay, so my property of square roots says I can also separate these all into different radical terms. So the square root of 4 times the square root of 4 times the square root of 11 times the square root of a squared. This property says that these are equal expressions. Now I need to simplify. That means find the square root. What's the square root of 4? 2 times 2 times the square root of 11. What's the square root of a squared? A. Because a times a is a squared. So now we need to simplify here by performing operations. Oops.
4 times 11, or no, it's 4, and then the square root of 11a.
Okay, is a under the radical
Yes.
sign?
Yes.
We just found the square root of it.
No.
So it needs to be outside the radical sign. Good. So 4a radical 11 is the simplified variable expression.
The radical
That-
and the thing with the radical and square root are the same exact sign.
It is the same sign.
Oh.
The radical symbol, you take the square root, that's the verb, and then the radical is the noun. So we're going to be in the semantics of that. Any questions on this? So the steps are the same, but remember, when you factor out a square root of a variable, it goes outside, okay? Here we go. Oops. Yeah. All right. Now, we're going to talk about, we did with multiplying, now we're going to look at fractions here, okay, and dividing. So, here's my example. If I have the square root of 100 over 4, That is the same, well, do what's inside the radical first, right? What's 100 divided by 4?
20, 50, just
25, right? Okay, and the square root of 25 is 5. So behind this lucky green number door is another equivalent expression. Because isn't this the same as saying I can take the square root of the numerator and take the square root of the denominator? And that would be, yes, now the square root of 100 is 10, square root of 4 is 2, and then divide that, I get 5. Those are equal.
Yeah, but wouldn't the first one be easier?
Sure. So that leads me to this property. I'm going to move this out of the way. The quotient property of square roots. You can find equivalent expressions when you're trying to simplify them. Okay? So we're writing this down in your rule box, in your notebook. Basically, if you have two numbers that are greater than or equal to 0, we don't work with negative numbers inside the radical. You're dividing numerator divided by denominator. You can take the square root of each one separately and then divide. Those are equivalent. And so here it is with numbers. If you wanted to say the square root of 11 fourths, well, just take the square root of each of the top and the bottom separately. And you'll get the same answer here. Square root of 11 over square root of 4. That's a perfect square. So square root of 11 halves is just simple expression. Okay, but this is another way to simplify a radical expression. Just look at fractions.
But what is the, I can't read what the,
We are going to simplify a radical expression, so there will be fractions here. And here's my expression. Oh, and there's variables. Yay, that algebra. Here we go. The square root of 49 over 121x squared. Hopefully those numbers look familiar to you. As I said last time that you need to remember some of these perfect squares. Over 100. Sure. So let's see. Quotient property of square roots. What does that tell me to do? Division. Well, before we do division, yes, that's true. I can take the square root of the numerator and also the square root of the denominator. Okay? That's how we can have equivalent expressions. Okay? To simplify it. Now, what is the square root of 49?
7.
So 7 over, okay, that is like 121 times square root of x squared. You can also separate it, right? 11. So 7 over 11x. That's it. That's all we can do. You can leave it as a fraction, so don't get into a decimal. Okay? Any questions on that? Before you get to try that. Okay, so you're going to simplify the expression. These 4. 1, 2, 3. Oh, actually, I said 2 and 3 in your notebook. So go ahead and, all right, the expression, the square root of 16x over 9, gives the maximum speed in nautical miles per hour that a certain boats can travel, where x is the boat's waterline length in feet. So I had to look this up. I'm like, what is the waterline length? Okay, so that means, like, even though it's not as long as the actual boat length, it is where the water, where it covers from the water, so it may start here and then it goes to there. Okay, this is the length overall, LOA, from, stem to stern. So, we want to write this expression in simplest form.
Oh,
We have a radical expression.
yes.
Okay, so I'm going to write my expression first. So, square root of 16x over 9.
So 4x.
Now, the quotient property of square root states I can take the square root of top and bottom separately. It's equal. So, right, over square root of 9. I can even separate the terms in the numerator as well.
So just 4.
What would that be?
4 times the square root of x over 3.
Very good. These are both perfect squares. So 4 root x over 3. So there's your simplified expression. And we're going to use this expression to answer the next part of this question, which says the boat's waterline length is 30 feet. So that's important here. Use this expression to approximate the boat's maximum speed.
Wait, so why?
16 times 30 over 9.
No.
Okay, now where am I going to use 30?
X.
Very good, this is x. Okay, x equals 30, so I substitute that in here, so here's my expression. 4 root x over 3. Then I will substitute, I always start with the original equation, or expression in this case. So 4 root 30 over 3.
Can you be 4 root 10?
3 and 10.
The answer. Because
Well, it is 3 times 10. Are either of those perfect square factors?
yes.
No. So, when I want to approximate here, I'm actually going to find the square root of 30 and multiply it by 4, then divide by 3 to get my answer. Okay.
Wait, hold on, I thought we were supposed to do that.
Well, in this case, I want an answer. I need speed. So I want you to actually compute the square root with your calculator. Okay? Multiply it by 4 and then divide by 5.
So yeah, it's 30.
40. What is root 30? What is root 30?
40.
This is like the same as saying 4 thirds times 5.477. Well, you could do this times, for your numerator, divide by 3. What do you get?
47.
Careful, you didn't divide.
Oh, is that what the answer is for?
Okay, yes, it is. It's 7.3 nautical miles.
No.
Okay.
See, that's the answer.
So we simplified the expression and substituted it in.
Can you do 5 to